Section 5.1 talks about verifying trigonometric identities. Chapter 5 is all about identities, and I will tell you right now, it is one of the most confusing and boring chapters. It's boring because you do this stuff over and over again. It's confusing because there's literally 50 different identities that you guys need to remember. How many of you guys like doing jigsaw puzzles? Wow. A couple of you. Okay. Well, instead of jigsaw puzzles, let's think about doing crossword puzzles or doing word search or even playing Candy Crush or anything else like that. They're all puzzles. You try to determine what the pattern and sequence is, right? Because on those repetitive games, there's no way that you're going to beat the game unless you start to determine what the pattern is. Because if you're just firing randomly, whatever, you're not going to win. Don't fire randomly here, okay? You've got to know these things. They're puzzles. We're going to talk about the fundamental trigonometric identities. And these are the fundamental trig identities. We have 6 here, 2 here, that's 8. There's 3 here, technically there's 9. So that's 17, plus another 6, that's 23 right there that you got to know. The Pythagorean identities, from each one of these I can generate 2 more. And we'll talk about that in a minute. The first one that we talk about are the reciprocal identities. And we've actually talked about this before because we've talked about the fact that if sine is equal to opposite over hypotenuse, cosecant is equal to hypotenuse over opposite. That's a reciprocal, right? Therefore, sine of x is going to be 1 over cosecant of x. Just like cosine of x will be 1 over secant of x, tangent of x is 1 over cotangent of x, cosecant of x is 1 over sine of x, secant of x is 1 over cosine of x, and then cotangent of x is 1 over tangent x. Reciprocal. That's it. Okay? That's all you got to remember about that. You've got your quotient identities. There's 2 of them. You've got tangent x, which, as we already know, is opposite over adjacent, which means the sine of x is opposite over hypotenuse, the cosine of x is adjacent over hypotenuse, and the hypotenuse divides out, because if I do that as O over H over A over H, those h's will divide out, leaving me with O over A, which is sine over cosine. And since cotangent is a reciprocal of tangent, it follows that cotangent would also be equal to the cosine of x over the sine of x. Then we have, yes, Jesse. Yes, you can. So yeah, you can even develop more, but that's one of those that we don't use a lot. We don't write it down per se because we're going to talk about how you develop other identities, so that's coming. Now, the Pythagorean identities here. This one right here, sine squared of x plus cosine squared of x is equal to 1, can be rewritten in 2 other ways. If I subtract sine from both sides, I get cosine squared x is equal to 1 minus sine squared x. And if I subtract cosine squared x from both sides, I get sine squared of x is equal to 1 minus cosine squared of x. Okay? By the same logic, I can do that with 1 plus tangent x equals secant squared x. I meant tangent squared x equals secant squared x. And I can do that with 1 plus cotangent squared x equals cosecant squared x. Okay? Now, this is kind of a mnemonic. This is how it helped me. The 1 plus cotangent is associated with the cosecant because they both start with C. Cotangent is going to come first because cotangent, COT, is alphabetical in front of cosecant, CSC. That's how I remembered that one. 1 plus cotangent squared x equals cosecant squared x. And then I took that to help me remember this one. If it's 1 plus cotangent, it follows that the other one has to be 1 plus tangent. And if that one's equal to cosecant, this one has to be equal to secant. It's a little convoluted, but it helped me remember. That was back in the, I don't know, 9th or 10th grade when I figured that one out. And it's up to you how you guys remember these. But like with the 1 plus tangent squared x equals secant squared x, that can be the same as tangent squared x is equal to secant squared x minus 1, or 1 is equal to secant squared x minus tangent squared x. Yes, Jesse?
Wouldn't you take the first Pythagorean identity and count sine squared x sine squared x plus 1 and turn it into the second Pythagorean identity by dividing both sine by cos squared x?
And that's exactly how you do it. It all flows from that first one, which flows from a squared plus b squared equals c squared. Okay? It's a lot easier just to remember these three. Okay? It really is. But what he's saying is, look, if I divide through by the same thing, cosine squared x, what do I get? I get this right here. Okay? And likewise, if I divide it through by sine squared x, what would I get? This one right here. So really, there's 9 of them, but you only need to remember the first one. Okay? And the thing is all of this, everything that we're going to do in this entire chapter, flows from these first 23 fundamental identities. Everything else flows from it. Okay? So if I've got 1 plus cotangent squared x, and that's equal to cosecant squared x, that's the same thing as saying cotangent squared x is equal to cosecant squared x minus 1, and then I can say 1 is equal to cosecant squared x minus cotangent squared x. Okay? And then we're going to have our even and odd identities, which are important. I've already told you which functions are even and which ones are odd. Okay? The only 2 trigonometric functions that are even are the cosine and the secant. That means that the cosine of negative x is the same thing as the cosine of x. And the secant of negative x is the same thing as the secant of x. Whereas the other 4 are odd. If I find the sine of negative x, that's the same thing as negative sine of x. If I find the cosecant of negative x, that's the same thing as the negative cosecant of x. If I find the tangent of negative x, that's the same thing as negative tangent of x. And if I try to find the cotangent of negative x, that's the same thing as the negative cotangent of x. This is going to be important because we're going to use all of this to verify identities and to create new identities. And we're also going to use it in Chapter 5 and Chapter 6 to help us solve application problems. And this stuff right here, this chapter right here, if you remember nothing else from this course, I suggest you commit Chapter 5 to memory. Because next semester in Cal 1, this stuff is going to come roaring back at you. And it's going to be even worse in Cal 2. You need this stuff to be successful in calculus. I cannot stress that enough. Okay? You need to know this. And no calculus teacher that I'm aware of, and I've had a bunch of them, and I've sat in on a bunch of them, will let you use a formula sheet. They're just not that nice. That's why I'm not letting you guys use a formula sheet. I'm letting you know what's coming. Because as confused as you are now, it only gets worse. Okay? Which is why you need to be working on this stuff on a daily basis. Be honest with yourself. Do you spend at least 30 minutes a day on this course? I would guarantee that at least 70% of you do not. Because I know what you guys are like. Hey, the test isn't until next Tuesday. I don't have to study. I'll study Monday night. It'll be about midnight. I'll pull out the book, glance at it for about 15 minutes, and I'll crack an A. Not going to happen. Okay? I'm telling you right now. And one of the most common comments I get after I hand back that first test, this is the hardest math test I've ever taken. Duh. It's supposed to be. Because this is the hardest math class you've ever taken so far. So naturally, the first test will be the hardest math test you've taken so far. Until you get to the second one. And then the third one. And I'm not trying to scare you. I'm not trying to be facetious. I'm trying to tell you like it is. Because I already know, I'm looking at the grades in my math lab. I know how many of you are actually working on it on a consistent basis. I'm trying to help you guys. All of you can do this. You have to make the commitment to spend the time to do it. There are no shortcuts. You have to spend the time to learn the material. Okay? And if you were a prodigy at math, you wouldn't be in this class. You would have already taken this class when you were 12. Okay? I know a few like that. They're scary. Scary, scary people. I had an instructor when I was in college a long time ago, first time, when he was doing his PhD work at Michigan State. And there were two kids there in their postdoctoral work. One of them was 14, the other one was 16. Postdoctoral, okay? For fun, they would go to the math library, because Michigan State has separate libraries and they would just run through the stacks, grab a book, run back to a table that they were both at, flip it open, point to a problem, hand it to the other kid to see who could finish first. Scary kids, very scary. As much as I love this stuff, I would never do that even now. Okay? But I do understand the commitment required to do this stuff. All right, let's look at this one. We want to verify the identity. And this one, we start out with some easy ones. Now, when I say verify the identity, you must work on one side of the equal sign or the other. You cannot cross the equal sign. You are not dividing through by stuff. This is not an equation. This is an identity. What's the difference between an equation and an identity? Jesse?
An identity is given and not proved. An equation written like this must be rewritten so that it is equivalent as an identity before it can be accepted as true.
Okay, that'll work. Let's say this, though. An equation, you solve for a variable, and there's going to be mainly one answer. If it's an identity, it's true for all values of the variable. So an equation, I can rewrite it as an identity as long as it's true for every single value of x that I can come up with. So what this is saying is no matter what value of x I put in there, the cosecant of x times the tangent of x will always be the secant of x. Always. So that means that the cosecant of 30 degrees times the tangent of 30 degrees must be equal to the secant of 30 degrees. Likewise, the cosecant of 210 degrees times the tangent of 210 degrees must be equal to the secant of 210 degrees. No matter what value I put in there for an angle, it will always be the same on the left as it is on the right. That's what an identity means. So identities are true for all values of x. Okay? So how do I verify that? Well, basically, I'm going to take the scalpel, the laser, and do some creative cosmetic surgery to one side to make it look like the other side. Okay? That's really all I'm doing. I want to transform one side so it looks like the other side. Math is manipulation. Always. Always has been, always will be. It's all about manipulation. So what I'm going to do is use the fundamental identities that I know, which are these up here, to rewrite this so that I can change the left side into the right side or change the right side into the left side. Now here's the kicker about it. I can work on the left side for a little while and then stop and jump over to the right side and work on that if I want. I cannot work on them simultaneously. Okay? So, cosine x, tangent x, secant x. You can do a couple things with this, but let's start with the left-hand side. And I know that the cosecant of x is the same thing as 1 over the sine of x. Okay? Actually, I should do this. So I've gone ahead and changed the cosecant of x into the 1 over sine of x. I'm going to multiply that by the tangent of x. I also know that the tangent of x is equal to the sine of x over the cosine of x. Okay? And that is still going to be equal to the secant of x. Technically, I should be thinking in terms of a question mark. But when it says verify the identity, we're going to assume that that is a true statement. I just have to make sure that it is the same on the left as it is on the right. Now, on the left-hand side, I've got 1 over sine x times sine x over cosine x. I know that sine x will divide into itself, leaving me with what? 1 over cosine of x. And I'm still saying that this is equal to the secant of x. And that's true because by the reciprocal identity, right up here, the secant of x is equal to 1 over cosine of x. I can rewrite this as secant x equals secant x. It's at this point that I have verified the identity. I took the left-hand side, changed it so it looked like the right-hand side. At no time did I cross the equal sign. Okay, now I know the Berlin Wall no longer exists. Okay, but this is kind of what the equal sign is like. Better yet, let's use something that's a little more extant, the DMZ between North Korea and South Korea. That still exists. Probably will exist for millennia to come. You can't cross it without getting blown up by a mine or shot. Okay? Don't cross the equal sign. I know it's a stupid mnemonic, but it's going to help at least one of you remember that. Okay? Don't cross the equal sign. All right, so let's look at another one. I want to verify this identity. The cosecant of x times the cotangent of x plus the sine of x equals the cosecant of x. Now here's kind of a hint. Which do you think will be easier to transform? The left side or the right side? That's the way you want to look at it. This is going to be easier to make smaller. That's going to be a whole lot harder to make bigger. Okay? You want to simplify, not complicate. And I can only use what I have. I can only use the identities that we have in existence at this moment. And trust me, there are plenty of others. They all flow from this. I mean, this is an identity right here, and I can use this later on if I want, if I happen to remember it. I'm not going to remember that one. But what I want to do is I want to look at this and go, okay, how can I change this to get to cosecant of x? In the back of my mind, I know that cosecant of x is the same thing as 1 over sine of x. I don't have any 1 over sine x in here yet. I'm going to get there, though. If I look at cosine x times, excuse me, cotangent x, I know that that is going to be the same thing as multiplying cosine of x by cosine x over sine x. And I still have plus sine x. Okay. So what do I have? Okay, I've got cosine x times cosine x over sine x plus sine x. And I'm saying that is equal to the cosecant of x. Now, let me say this. Notice that I am putting the variables in each and every one of these. If on a test you guys do this, I won't even grade it. It'll be a 0 automatically. Because that makes no sense whatsoever. All trigonometric functions must have an argument. If they don't, it's nothing. Okay? Don't do that. Okay? Really. So anyways, what do I have now? Okay, well, I got cosine squared x over sine x plus sine x. And let me just write that like so. And I'm saying that this is equal to cosecant of x. What I'm going to do now is change sine x over here to sine squared x over sine x. Because this right here is a fraction, right? This has a denominator of sine x. What does this have a denominator of if I want to add it to this? Well, right now it's got a denominator of 1, right? But I don't want it to have a denominator of 1. I want it to have a denominator of sine of x. Which means that the cosine squared x over the sine of x plus this sine of x over 1 will be multiplied by sine x over sine x. And that's still going to be equal to the cosecant of x, supposedly. I'm almost done. Bear with me. We'll finish it up. So now what do I have? Well, this whole thing is going to be the cosine squared of x over the sine of x plus sine squared of x over sine of x. And that's still hopefully equal to the cosecant of x. But now that I have a common denominator, I can rewrite it as a single fraction. Cosine squared x plus sine squared x all over sine of x. I'm still saying that's equal to the cosecant of x. What's the cosine squared of x plus sine squared of x equal to? 1. Very good. Because it is a Pythagorean identity. Don't get confused because up here we wrote it as sine squared of x plus cosine squared of x. Because addition is commutative. I can rearrange the terms. So this becomes 1 over sine of x. I'm saying it's still equal to the cosecant of x, and we know now by the reciprocal identities that this will be the cosecant of x equal to the cosecant of x, and I have verified the identity. It's a puzzle. I want to solve the puzzle. I gave you a puzzle at the beginning of the semester, didn't I? And you had to get creative to solve that puzzle. Sometimes you're going to have to get creative here. Okay? There's way more to this, and we will cover it in detail, nauseating detail. Okay? All right, we're done for today. If you have questions over the weekend, you can call me on my mobile number, you can text me, you can email me. If you call and get my voicemail, pay attention to what it says. It says, send me an email. If you text me, follow it up with an email. That way I know that you have tried to communicate with me, and I will try to get back to you as quickly as possible. I'm sorry? It's in the syllabus. It's also in Blackboard under faculty. Yes, Jesse.